Hello and welcome to this section. In this section, let's learn about the use of 3D World. In this section, it mainly includes the following 3 knowledge points, namely, the feature overview of 3D World and the characteristics of 3D World. Finally, we will cooperate with the characteristics of 3D World to carry out a practical exercise for you. First of all, let's take a look at the 3D World feature overview. The so-called 3D World is a widget that uses WebGL to achieve 3D effects in H5. It is similar to Canvas. It is a container. The 3D World can be used to display 3D models, make 3D animation 3D games, and achieve more smooth effects to achieve panorama. Before using new widget to achieve a series of effects. In order to facilitate your understanding, I will first take you to see a series of effects that we have made in the 3D World. In order to facilitate your understanding, I will take you to see the application that we have made in the 3D World. First of all, it is such a butterfly application. When I slide my finger upward and the mouse moves forward, I can see the series of contents behind it just step back, so I can have a back and forth effect. This is actually very similar to what we do. Is it such an effect when we do it to the end before? As for the marketing interaction case we showed before, can we see that there is a countdown of forward sliding at the annual meeting? We can use our 3D World technology to do this. In addition, we just mentioned that the 3D World can also be used to display a model. For example, this is a 3D model. We can upload it to our 3D World, and then view such a model, its various effects, and then turn on its 1A rotation of a camera, and then we can view an effect of such a model 360 degrees without dead angle. In addition, we just mentioned that we can also do a 3D game in the 3D World. Let's take a look here. For example, here is a specified time. He wants you to find a corresponding treasure chest, and then you find the corresponding treasure chest, and it will have a prompt. Here, since I already know where it seems to be, I'll just point it out directly. I'm here so that we can complete the production of a game such as a 3D World. This is a typical game made with a 3D World. This game is also sold in our template center. You can buy it and use it. After a simple demonstration, we continue to enter our 3D World and learn its content. Then we will learn some very important features of the 3D World. First of all, it is its first feature. As a container widget for making 3D effects, the 3D World itself cannot achieve various effects alone. It is necessary to add widget in the interior and cooperate with the camera perspective to complete the 3D effect. Therefore, we must pay attention to a very important point here, that is, the internal 3D coordinates will not change. The perspective we see is the camera we added in the 3D World, and the content it captures is the content shown on our screen. We must pay attention to this point, which is the most basic content for us to learn 3D event. Then let's talk about the first point here, is our coordinate system. You can see that in the 2D environment, it is downward as the positive direction of the y-axis, and right as the positive direction of the x-axis. Is this completely consistent with the coordinate system we locate in the absolute positioning environment? But the coordinates in our 3D World are not like this. It is vertical, the top is our y-axis, and then the horizontal right is our x-axis, and then we go inward in our own direction, which is a positive direction of the z-axis, and then our camera looks in this direction. Then these 3 directions determine a positive direction of our xy axis. Then, if the value corresponding to it is larger, the more it will go in this direction. If the value is negative, it will go in the other direction. What we need to pay extra attention to here is that our z-axis is used to record a depth of our object, and the direction towards us is a positive direction, and it is a negative direction towards the interior of the screen. Again, in the case of 3D, the angle of view that we slide and switch is achieved by rotating our camera, that is, our observation point. The 3D coordinate system corresponds to our 3D World itself. It is completely fixed. We can have a change effect. In fact, we are manipulating our camera to move. Then, let's talk about a unique thing in the 3D World called the center distance. The so-called center distance is that in the 3D World, in addition to using the XY coordinate to locate the object, we can also use the middle center distance to locate the object. The so-called center distance is that when the object is in the current XY location, we deviate again move a distance of r, and the direction of this offset is determined by the XY rotation of the object itself. The function of r is equivalent to introducing a polar coordinate system, which can help us better locate an object in spherical coordinates. Here we have a simple demonstration for you. For example, we have an object whose xy coordinates are as x is 100, y is 0, and z is 0. Then on this basis, we can set an r and adjust the direction of r through the rotation of the xy axis of our object. We can take it as an x equal to 100, y equal to 0, and z equal to 0, which is used as a star for positioning on the radius. When one of the rotations of x and z is 0, its r direction is completely parallel to our z-axis, which shows such an effect. Therefore, here we can make an additional explanation for you, that is, what is the use of our center distance in general. Cooperate with us to make a rotation effect to carry out a positioning. If we want to make our camera move back and forth, we'd better use xyz coordinates dot, and then down as one of our spindles. In our 3D world, all widget can pass through the XYZ axis rotates 3 parameters to control its rotation angle. The 3 different rotation angles depend on the direction of the XY3 axes of the object respectively. Its property represents the positive direction of the current widget around the 3 axes of its internal middle distance, and the angle of rotation in anticlockwise direction. How can we understand the direction of the axis? We will also cooperate with our actual cases in a moment to help you to make a rational analysis. Yeah, I won't say much. Let's directly carry out our practical practice. In this course, what we want to complete is such an effect of butterfly flying to the end. So first of all, we open our editor. Here we input the application name called One and All, and then click Create. Then we first form a good habit. We add a page under the front end, and then we will add our 3D world under the page. Where is the 3D world widget? In fact, on the right side of our panoramic container, we select our 3D world. We click it to add a 3D world under our page. We can see that here we can already see a basic effect. We can see that it is completely consistent with what we just said. The positive direction of the z-axis is towards our z-axis, the negative direction of the axis is toward the inside of the screen, then the right is the positive direction of our x-axis, and then the vertical upward is the positive direction of our y-axis. Then we can notice that when we add a 3D world, we bring a camera here. So if we delete the camera, we can't see anything in the 3D world. Then, in order to see such a butterfly, we first need to add a butterfly. How can we add it? Let's go back to in our 3D world, we select our 3D world, and we can see that there is such a widget called Picture on the left side of it. This is the picture we have in the 3D container. We click it, and then we go to upload a material of such a picture. We can see that such a material has been uploaded, and then when we select this when it comes to a picture material, we can find that it has not only an property like skin map, but also a normal map, including a material effect, light map, light intensity, etc. This series of content is a very complex content in our 3D. Only when you have a complete grasp of this series of content, can you make a 3D game like the one we just played. This content is very huge, so we won't give an in-depth explanation in our marketing interaction topic. If you are willing to listen, we will open a new course in the follow-up to talk about a tutorial on how to make games in the 3D world. Then, because we added such a picture, we can see that this is a perspective of our camera from the perspective of our camera, and he can see this picture. So when we do the preview, we can see such a picture appears in such a position. Then we can see that the current picture actually looks a little narrow. We can slightly adjust its size. For example, its original width and original height are 100. Obviously, its width should be higher, so we adjust its width to 200. In this way, it can have a normal one it shows. Then let's take a look at this material. We can see that the first thing we see is a butterfly, but when we slide up, there are a series of butterflies behind it. So we know that a butterfly should be added behind this butterfly. What should we do? So it's very simple. Let's copy the butterfly and paste it in 3D time. Now we find that pasting has no effect. Why? Because the two butterflies completely overlap, because one of its XYZ coordinates and center distance are exactly the same. So we choose the second butterfly. We want it to be on the inner side of our screen, so we adjust it, right? You see, this is a positive direction of the z-axis. We want it to be more inward, so we're going to make its z-axis smaller, right? So let's lower it to a position of 100 pixels, and you can see that it reaches the inner side, but when it reaches the inner side, it is completely parallel. We can have a look at the two butterflies, right? The two butterflies are completely parallel. We can't even see a particularly obvious effect. In order to achieve the effect of a little rotation here, we must set a rotation angle for our butterfly. Let's take a look at its rotation setting. It has set the origin as the center by default. We can take a look. Which axis do we want it to rotate around? Let's take a look. If it's the y-axis, how does it rotate? Is it like our mobile phone rotating left and right? Similarly, if we rotate the x-axis, is it a folding effect up and down? So what are we going to rotate in the end? It's our z-axis that rotates, right? Therefore, we select a z-axis rotation here, and we add a 30-degree rotation to it. We can see that it rotates 30 degrees around our z-axis, so that our second server is ready. Similarly, we copy and paste another copy, and here we can increase the rotation angle for it. We add another 30 degrees to become a 60-degree rotation degrees, and then let's make it a little more inside into A200, so we all know the next steps. We can do a batch copy and paste. For example, when we reach the fourth, it will become A300, then the next will be A400, then the next will be A500, and then the next will be A600. If we want a change in the picture, what content should we set? That's right. As I just said, what is the basis of any content we can see? Yes, based on the appearance of our camera, we select our camera and add our gesture control for it. There are many methods of gesture control here. What do we want from it? Do a translation back and forth, right? So let's choose an effect of forward and backward translation. Then we can have a preview here, and we can also see that with my translation now, such an effect has appeared, but you can see that if I slide very far, it will become very small. If I cross, there will be no content in the whole screen, so here we can control one of its gestures. One direction of the z-axis is also set. We can see that it has a maximum z and a minimum z here. We can notice that its camera is located at a position with a center distance of 300 at present. Therefore, it has a positive distance of 300. The default coordinate here is 0. So if you don't want it to be able to go back after previewing, your maximum z can be set to a 0. Then, since the forward direction is the negative axis, it is the smallest, so you can set it at will. Here I set a -700, let's have a preview to see an effect. We can find that when we step back, such an axis will not shrink. Then we move forward to such a distance of 700, and this can't shrink anymore, so we will definitely finish the above as the whole content of this section. Thank you for watching.